I am Theo from JOBANTALENT, and I'm going to tell you a little bit about how we broke our initial monolith and when the microservices path. On that path, we went to having more than 10 million users and being in quite a few countries, and especially, more specifically, we multiplied by 5 our engineering team. This is me. I'm Theo, the VP of Engineering. I've been with JOBANTALENT for almost 2 years now, which is a lot in startup time. I apologize for my little English mistakes. As Celia Cruz used to say, my English is not very good looking. So let's start this. So what is the mission of JOBANTALENT? I'm going to tell you a little bit about JOBANTALENT to begin with, otherwise it might be weird. Our mission is basically to stop unemployment in the markets where we operate. That means a lot. That's kind of a big, bold statement, but it's really what we want to do, and make a business along the way. How do we do that? You probably know JOBANTALENT for some time, maybe, especially the brand has been there for 5 or 6 years. And the reality is that we've been pivoting a little bit from the beginning, where we were a marketplace to find jobs for graduates, people just out of university, top employers. We've been doing quite a lot of things, improving our recommendation system mainly. In the last year, we've been focusing more and more into the payroll model. The payroll model means that we want to close the loop. We want to have companies advertise with us their job openings, and then actually provide them with a person, with a candidate that will apply to us. We will hire him, and we will offer this person to the company as a service that he pays, or he or she pays weekly. And we also pay weekly to the candidate, which is quite a difference in some countries. The main difference with regular ETT or temp agency in English, Adecco, Randstad, the main difference is that we just have the same business model, but there's nothing else that is the same. We have an app, we have matching in real time. It's quite a different experience for a company. If you go to Adecco, they take maybe 2 weeks to provide somebody, or at least 2 days, and we want to do it in a couple of hours, signing the contract and everything. We have quite a lot of things that other members of the industry don't do. So very quickly, what's the flow for companies? We want them to hire the best talent in 5 minutes. They post a job, they find immediately the matching candidates, they talk to them, they post the offer and a salary directly via the app, and then the person gets hired. The candidates just get a push notification on the application, apply, they sign up, they get a push notifications, apply, and basically they are hired. Obviously, there is quite a lot of back office to do that. There are even some manual operations still, but we want to do this as efficient as possible so we can charge way less to people. And actually, at the end, people get hired. We send them a box with some t-shirts and some glasses just to say, good luck in your new adventure. So we've been growing a lot, almost 10 million users, especially in Spain, Mexico, the UK. We have quite a big team on the product side. We have more than 80 people, some doing product, engineering, design, product, and they're coming from many different companies. The team that we are assembling it's very good. It's one of my best teams ever. But we are all here to talk about microservices. The commercial part is over. But not really, I lied. We're not doing microservices at JOBANTALENT. We do services though, and that's a very different thing. Microservices tend to grow in number very easily. Netflix and the main microservices practitioners, they say we have hundreds of microservices, thousands of microservices. We do not go that way. Our services are very small and single purpose, but still they do more than one endpoint or more than maybe a little bit more than one thing. So why did we go with microservices? Especially because we were growing a lot. We were growing at peak rate. We were growing at 1 million users per month. We're doing a lot of activity in the platform because people tend to come back a lot because we have, it's a mobile platform, it's a mobile app. Actually, we shut down our website for candidates a few months ago because we wanted to focus on mobile. We were doing 20 million job matches per day, matching new job openings to candidates, and we were growing a lot in servers. And there is also something interesting is that we've been doing quite a lot of TV ads. Probably you saw some of them, and we were doing this, we call them internal moments at some TV programs like Gran Hermano or Big Brother. No, Gran Hermano, Mercedes Milá cannot be translated. And during 1 minute, Mercedes Milá or her wingman or wingwoman or whatever, the second, would mention Job and Talent, show the app, and do quite a lot of things about Job and Talent on the air. Unfortunately, Big Brother is probably the main TV program in Spain. It has the highest audience or share, and everybody could download the app, register, and we saw those peaks. If we had kept our initial monolith, well, this could be basically impossible. So let's deep dive into it. How was the Job and Talent monolith in 2013? Essentially, Job and Talent started, as I said, 6 years ago, and in 2013, what we had was a Ruby on Rails monolith. To be honest, if you have 4 or 5 people working on a project, as we did back then, a monolith is the way to go. If somebody goes and says, oh, you're starting a new startup, go with microservices, they've never done it. It's a lie. Basically, monoliths are quick because we couldn't be where we are if it wasn't for the monolith. They're quick to develop. It's easy for the developers to know where everything is. And this is what it looks like in theory, right? You have a very clean monolith, you know where everything is, and the team can deliver product very fast, very quickly. It's also easy to deploy, it's easy to monitor, is the service up or down? It's very easy to proceed. And technically, it didn't look like the Stanley Kubrick photo. It looked more like this. It's a regular Ruby on Rails monolith. They chose Ruby on Rails. Postgres database, Elasticsearch for searching, and some stuff to do background jobs with Sidekick and some Redis. Again, it's a very typical stack. It was hosted in a very cheap hosting provider in Germany, and it worked. We grew to quite a few million users, maybe 2 million users, and it worked. But the problem was that we were scaling the team. That means staff start to get locked, and it's complicated. So in reality, what we ended up was having this crazy painting that I use a lot in my presentation, which is the Triumph of Death from the 16th century, where apparently they knew already what software monoliths could be. And it was really complicated. We had lots of technical debt, which was not only related to the monolith, but the monolith helped. It was because we wanted to launch stuff very quickly. Also, team contention started to be a problem. It meant if you wanted to deploy something related to the recommendation system, you really need to match the timing with the candidate's application. So you don't deploy something that is in master. It is just complicated. Contention starts to happen. So in the end, everything slows down. It's really difficult to launch, to deliver new things, new features in the product, because the monolith is in the way. So how do we scale? That's our question. I'm going to have a little parenthesis here, a little bit of pseudo-academic territory. Will be really fast. So we needed to optimize for something. We have the teams, the organizational structure, the complexity of communication between components of the system. Maybe we want to make it very easy to communicate between systems. The complexity of communication within teams and between teams. That's also something that we could have optimized for. Speed, agility, maintainability, correctness. To be honest, there's no right answer. So we just pinpoint something, which is a team. We want teams to be autonomous. We want teams to don't collide. We want them to deploy new things very quickly without asking anybody else. And that's the role we took. That's the path we took. So there's something which is from the domain-driven design jargon, which is bounded context. Essentially, you can say that bounded context is this thing between the lines, which is the same concept. In this case, a customer or a product has two models, really, or maybe three or maybe four in each of these contexts. A product or a customer is completely different for a sales guy than for a support guy. Actually, different even when they talk in real life. They have different, they attach different properties and data to each of the models. So the reality is that we wanted to go this way. Essentially, you have, in our case, we have the job opening, right, which is one of the essential models or concepts of Job and Talent. It's a job opening. There is a job opening for the candidate system, which is a Ruby on Rails system. There's a model, actually a Postgres database with all of the job openings, and it has some properties, some data attached to it. But then in the recommendation system, the same job opening has a different set of properties, different set of data. This allows each team to basically do whatever they want with the data, as long as they are synchronized. When you change the job opening in the canonical source of truth for the job opening, the whole system should synchronize with it at some point. Or a transformation of the same data, or just a part of the job opening that you're interested in. So if you're not interested in the big description of the job opening, you don't need to keep it in your service. So shutting down the parentheses here, how do we scale? Well, we decided to break the monolith and go towards the bounded contexts / services architecture. There's a lot of heresy from microservices practitioners in this presentation and the way we do things, but it's actually working. Breaking the monolith sounds easy, but it's not. It is difficult to not break things, and we broke things quite a few times, but what we knew is that rewriting the whole thing was not an option, because we could have to stop 3 months, 6 months, which actually turned into 1 year, because rewriting is always very difficult, especially at a big team already. So we went from this stack that we saw before to something more like this. What we did was, do we have a laser? Ooh. So we have this candidates application is the original monolith that is still serving our API today. And we started to take modules, single responsibility modules of this monolith and take it away and make them communicate via HTTP APIs. We applied the bounded contexts idea in which some of these boxes here, some of these microservices have copies of the data. So copying data is fine. It's okay as long as it's justified. We took, for instance, the suggestions and recommendation engine, which was a module in the original monolith. We took it out. We exposed an HTTP API. That took quite some time because it was our first extraction. But it worked. When the candidate's monolith needed to ask for recommendations for a candidate, it could just call an HTTP endpoint. Basically, by not writing much code, we were able to scale the recommendation system completely horizontally and away from the candidate's monolith. Obviously, you have to take the data. If you keep the data in the original monolith database, you're not doing it right because you are immediately you're fucked up. You're linked to the monolith and the models. The next thing we did was take out the CRM or company's part of the original monolith, and then some services actually were born being a service by their own without taking them from the monolith. So the communication between those services is usually an HTTP API, and the message bus, which is the horizontal box here, the red box, is for asynchronous communication, which I'll talk a little bit before afterwards. There's something also interesting, which is each service can have a different technology. We were a Ruby on Rails shop, and not anymore. Along the way, we've been using more JVM, Scala, Java kind of thing from that ecosystem, especially for the recommendations engine, which has a very big ecosystem for the recommendation software. We have Go for geo services and internal things. We have Ruby, but plain Ruby or Sinatra application. So we're going to a multi-technology stack. And the good thing about this is that the coupling is very loose. We have very loose coupling between all of these services. The anatomy of one of these specific services is always something like this. We have a application server layer, which is auto-scale. We have a background processing layer, which is also auto-scale, and a persistence layer. Persistence layer, we have Postgres or Elasticsearch or DynamoDB. And the important thing is that they all communicate through the RabbitMQ bus to communicate asynchronously to other services. And the very important thing is that you can automate this. And you have kind of blueprints of services that you can copy and paste. And you have a convention on how you do new services at JOBANTALENT, and you just follow them, and you know that it will be easy to explain. So we try to keep homogeneity. So what were the pros for us? We were able to scale the platform. We were able to, for instance, take away the recommendation system or the push notification system and have different services with different databases that we can scale independently. We were able to obviously scale the team, which was the main goal. And we were able to, in the end, eventually be able to scale the product faster. We were able to launch new things, which at the end is what we want. We want business impact. We want to tinker with things, but if we cannot scale the product, well, the company is dead. But in reality, what I wanted to tell you about is the challenges. It's a very difficult thing to do service-oriented architecture, or microservices, or whatever you want to call it, because communication is complicated, coordination is complicated, and especially at the end, you increase complexity, right? Communication problems, you have communication breakdown between services. Oh my God, you changed the API, you didn't tell me anything. Communication between teams, because in the end, there is a little bit of synchronization, because some teams need whatever service the other teams are providing. And the databases are separated, so you cannot do joins. There's no joins is a very, it's something that you take for granted, but then when you separate databases, you cannot do them anymore. And this is complicated to explain to some engineers like, my God, active record, I want to do /.join, whatever, and you have all of the data, 3 gigabytes of data in memory. That cannot happen anymore. And also, the coordination of API design gets more difficult. So in the end, what we have is more complexity. That's kind of the thing. I'm going to tell you a little bit about each of these challenges and what we've been trying to do to solve some of those problems. So communication. Again, as I explained before, we have HTTP APIs for synchronous communication, which we try to avoid. Don't use HTTP APIs or whatever, RPC, if you can avoid it, because it's kind of in the critical path. If you have a request coming to your API and you need to do many HTTP or RPC calls, which are synchronous, there's a critical path, and at some point you're going to time out. Either technically time out, or the user is going to just get tired and go to something else. So they are important, but we try to avoid them, and we try to go with the message bus. We try to go asynchronously as much as possible. So, for instance, a synchronous call would be the candidate's API calling the suggestions, the recommendation system, just saying, hey, what's the list of the most recent job openings recommended for this user? That's kind of cool. As we were discussing before, we have clients for using the services, so it's very easy to use one service from the other. You don't have to program the whole HTTP requests lifecycle. We cache it. We try to make it as fast as possible, blah, blah, blah. But the most interesting thing is the asynchronous way. So for instance, there's a new job opening that companies, this guy here, companies will go, you just go to the CRM, you connect to JOBANTALENT, you publish a new job opening, or through the mobile application, and you just save it in your database and publish a message to the message bus saying, hey, there's a new job opening. Somebody will be interested or not. In this case, the recommendation system will be listening to the job opening queue and say, oh, nice, a new job opening. Maybe there's some people in our database that will be interested in this job opening. So it will launch a recommendation matching process, take the first 20 candidates. This is already happening outside of the request lifecycle. This is already happening in a different box. And it will calculate it and say, okay, cool. We have these 15 guys. They might be interested in them. I save these matchings in my database and publish to the message bus saying, hey, I have these new matches between this job opening and these candidates. The candidates application will be listening in the bus and say, oh, nice. There are new suggestions, new matches for some of my candidates. They will take them, it will save them in their database, bounded context, and will send push notifications to the mobile application of the candidates through a different system, through the message bus. All of this is happening very easily and very transparently for the company's application. It doesn't know anything about push notifications or candidates. It doesn't have to. It just publishes stuff to the message bus. So if you can, go asynchronously. This is a lesson we learned along the way, painfully. Go asynchronously. So coordination, that's another complicated thing, especially on the data side, as data is completely separated in different databases. Not all of them are SQL. Some of them are NoSQL. Some of them are Redis, DynamoDB, or whatever. So to keep all of that data synchronized via the bounded context principle, we send them to the message bus. But the message bus will fail sometimes. So we have the coordination challenge here is making sure that the same job opening is it's synchronized. You have the latest version of the job opening everywhere. So we have versioned models. We have actually a cron thing that will go through all of the job openings in all of the services and say, do you have the latest version for this thing? If yes, okay. Otherwise, it will send the same message to the queue again. In the end, you have to make sure. It's very difficult to prove that everything is synchronized. You have to go and check, basically. API contracts is something that also helps with coordination. It's if you make sure that the contract for your service is public for all of the other teams, and that you have, if you provide a library to use it or just the contract, it makes it easy. For teams, it's a little complicated to have projects that are multi-team when you have an architecture like ours, because if they are multi-team, they are not autonomous anymore. It's very difficult to get them to talk. So what we do is we have a kickoff meeting, launching the feature technically, and saying, hey, this is how we are designing the feature. These are the services that are gonna be affected. Is it okay for you? And then you go with the first prototype. We go for a design review. So it's basically you need to talk. If people don't talk, you're fucked. And then testing is also a problem with coordination, in the coordination area of things. It's how do you do integration tests? How do you have all of the latest versions or the versions related to the latest branch for this feature in a staging environment? How doesn't it collide with a different feature which has different branches of the same services? Basically what we have is staging in a box kind of thing. We have, you can launch a new staging box that will take whatever branches you want of each of the services, and you have an endpoint, a public endpoint that you can send to the QA team or whatever. This is taking us quite a lot of effort and time, but it's really important. How do we tackle complexity? Complexity is many things. Complexity in the data, transactions, idempotence, and 3 dots. The complexity goes into the synchronization of data, as I explained before, the integration of data, which was our main problem to begin with. We have, it's a very data-oriented company. The CEO just goes and launches some SQL queries and just takes all of that data to Excel and does things. He can do SQL. When we splitted the databases, he almost killed me because it was like, I cannot do my SQL joins anymore. I have to do it. I have to connect to the production database. There's no production database anymore. So what we do is we take all of the different data pieces from all of the different services and integrate them in Redshift, which is the BI solution from Amazon. We just take literally all of the tables, we make a dump and make it available through Redshift. We have a 5 or 6 nodes cluster. All of the data is there. You can join them with SQL. We have dashboards sucking from Redshift. It was a lifesaver. At some point, you need to integrate the data so people can actually use it. Another piece of very complex things when we went this way was how do you do transactions? How do you make sure that something happened? The whole transaction, basically. How do you make sure that when you do something in the system, it's all or none, all or nothing? What you can't. We just got sick of it, and as everybody does, we just go with eventual consistency. We make sure that idempotence is possible in each of the services. We need, when you do something at JOBANTALENT, you need to make sure that if you take the same input for your system, it will not do the same thing twice. It will not send one push notification to the mobile application of the user twice. You need to make sure that you did already and don't send it again. Then we have quite a lot of things that happen when new people join the team, when new team starts spawning along the company, which is homogenization or whatever you want to call it. So what we do is we provide a set of building blocks for automation and tooling. We do, as Tiptano was saying before, we have DevOps in each of the teams. Actually, they do everything they need to do, and still they have some dependencies from the platform or DevOps team, which is not really what we want. We want each team to wake up at 3 o'clock in the morning and say, oh my God, my service is down, and not some other guy in a different team. We want you to be the owner of your services. So we provide a lot of automation, more and more tooling, and the building blocks that we talked about before. We provide a centralized logging system as a building block. We provide the message bus, which is very useful for our teams, and we provide a set of API guidelines how to design your API. But at the end, decoupling is hard. It's something also that the complexity of services architecture shows very easily. It's very easy to have a distributed monolith in which each of these little boxes from before depend very heavily on some of the others, on a specific version of them. My advice is invest in very good, simple design to begin with in each service. Just think it through and say, how coupled it is, how coupled is this piece of data to the piece of data on the other system. That's why distributed data helps, bounded contexts help, but it's not a silver bullet. Also, something that we learned along the way, that visibility is very complex in our architecture system, in a service architecture. It is very complex. It's something that we, again, learned the hard way. We launched new services without enough metrics to understand if the service by itself was working, and that's not good. Now we're investing quite a lot in a centralized metric system, which is already online. We had Graphite for a long time, and we are moving to Datadog. Request tracing, as a lot of people have mentioned already, it's something that we don't have, and we're investing in, because it is really important to know, since you get a request in the API layer, what happened in all of the other systems. This is a request ID. Did I send a push notification because this request ID? Did I send 100,000 emails because of this request ID? Or what happened, right? You need to be able to centralize all of this data and make it useful. And again, integrated dashboards, centralized dashboards of all of these little services help, but it's really something that you need to change your mind on. So if you can, invest in visibility, invest in a good alert system of each of the independent services, but also end-to-end functional alerting is really critical for us. So teams are full independent, they do continuous delivery, and they do DevOps internally. This tackles a lot of the complexity, but it is really, really difficult to have everybody understand that they're doing services. In the end, it's a matter of communication and training and letting people understand the challenges of what they're doing. The future. What we want to do in the future is horizontally scale everything. We still have some of our databases which are a monolith by themselves. We still have some Postgres databases that cannot be scaled horizontally. Just adding some read replicas is helping us, but still we know that this is not something that we can use in the next 18 months. We want to make sure that we enforce API contracts. We don't do it at the moment, and we still have quite a lot of problems because of that. It's complicated to communicate a change in your API to the whole team. So that's why if you have a contract and you have a new version, it just solves it automatically. We are also going the container side, the container path. We're migrating to Docker, to Amazon Web Services, the Elastic Container Service with containers. We already have quite a few services running there for everything stateless. We're not moving any state to Docker yet. We're not that crazy. And also we want to go with more managed infrastructure. I don't have any interest in the platform team managing the very last detail of every Postgres database in our infrastructure, because it is not that important. I'd rather have them working on tooling and horizontal services than working on the backups of my 30th Postgres database. So what we do is we're going with RDS on Amazon, DynamoDB, and just using more and more managed infrastructure, because otherwise it doesn't scale. So microservices at JOBANTALENT, it helped us scale to 10 million users. It also, really, what it helped us do is scale the team. That's what we wanted to optimize for. We also found out that it's not an easy path. It's actually very hard. My advice is wait for the right time. It's not an easy thing to rewrite a monolith into services. It's taken us years, basically. And if I could start something tomorrow, it could be a monolith. And designing the monolith in a way that it's easy to actually extract things and make them possible to be different services. So this is what I have. Thank you very much. But wait, I have time for questions, I think. Just like this. Hi.
My question is, you think about your experience in moving from a monolith to a microservices architecture. At my company, one of the things that we face every now and then, while doing so, because we're doing just the same, is that there's, let's say, there's an overhead of moving modules from being modules to becoming microservices, about just creating the machines specific for those, just scaffolding and stuff like that, and of course the implications that it brings in terms of performance, because communications, even if you just do them directly, for example, instead of adding additional complexity, by having the network in between, it's a bit more complex. So in general, there's this overhead, and one of the discussions that we have every now and then is whether it is the right moment, as you said, to move a module to a microservice. My question is, do you really do everything as a microservice, or say you start something as a module, and once it gets enough identity, let's say, or enough complexity, you move the module to a microservice?
It depends on which of these boxes the thing starts on. For instance, if it starts as a module for the API, it usually goes into the original monolith. But more and more we're trying to have separate services to begin with, because implementing a module within a bigger software application that can be extracted easily, it's a complex thing. It's architecting that, designing that in a way that you can easily extract it. We have best practices and we have tips to do it, but in the end, if you can do something, you do it, and you start coupling them, the module with the original software piece. So if we can, we go the service way, and we go the service way promoting the message bus to begin with, and HTTP APIs if needed. So the answer is, if you have a new service at Job and Talent today, or a new feature, if it has enough of an entity, it will probably go immediately to a service.
But then again, if you create a new microservice to start, from scratch, there's this complexity of just initiating the process of development. How do you ensure? How do you ease that bargain?
Yeah.
Like that?
So,
for example, do you have any automated tools for you to?
we have, for instance, a cookie cutter. I think it's cookie cutter. The name, Alex. Well, cookie cutter, yeah. So it's a template. Basically, it's a blueprint that you have for new services. We also have, if you provide a Docker file, it's easy to deploy for us into ECS. So we try to limit to kind of reduce the barriers of launching a new service as much as possible. We have the Docker for deployment, and Docker via Manuel, which is our chatbot for deploying. You basically go to Slack and say, Manuel, deploy my new service to staging or to production, and with very little work, you should be able to have a service online. If it needs persistence, Postgres database or a DynamoDB table or whatever, it takes a little longer, but we're working to have all of that as a self-service kind of thing. We are hiring. Actually, we're hiring across all teams. If you want to build this kind of service architecture and work with mobile applications that use them, please let me know. Thank you. We're hiring. Thank you.